So welcome everyone to this lecture. This is Ray Optics lecture number 20. And in this lecture, definitely we are going to complete this particular topic on ray optics. We have done with everything almost what we did in the last class. If you can remember, do you have your microphones? The mic working or not working? Not working? Okay. Sad. See, life goes on, even if it works or it doesn't work. Life has to move on. Anyways, in the last class, we had discussed microscope and telescope, compound microscope, astronomical telescope. We had seen their differences. So now we begin the last part of this particular chapter on ray optics, and which is defects of vision. What are the basic defects one has in vision? I am definitely having one of those because it's very hard for me to read smaller things. So I am probably not correct in my vision, and I'll be visiting an optician soon to get my vision corrected. But before I get to him, let us try to understand what are these defects of vision. Now, I hope you have some idea about these defects of vision, probably more idea than what I have at this point in time. Let us see if we can recollect some of those thoughts and discuss among them. It is coming to you right now on your screen. The first type of defect, as you can see, is known as myopia or short-sightedness, or you can call it near-sightedness as well. What happens in this short-sightedness or near-sightedness? It is very evident that the rays of light which are coming, these are the rays of light which are coming, and this gentleman is your retina. They are not getting focused on your retina. They are getting focused at a point which is, what I should say, on the left side of the retina. They are getting focused before the retina rather than on the retina. Do we understand this? So the things that I see, they are not getting focused on my retina. They are getting focused at a nearer point. This type of vision is known as near-sightedness or short-sightedness. Distant object will not be clearly visible because the rays will be getting focused at a point which is not on the retina but before the retina. I will not be able to see distinct objects, but I will be able to see nearby objects clearly. Definitely this is not the problem with me because I can see, as far as the vision goes, I can see everything very clearly. This is definitely not the problem with me, I am assured now. But some people may have this problem where they don't see the distance object clearly, but they can see the nearby objects very clearly. This type of defect is known as myopia or short-sightedness. These are the two diagrams that you must remember about this, because the question may be in the form of statement, it may be in the form of a diagram. What type of defect is this, and how are you going to correct this? So this defect, where rays are getting focused, distance rays are getting focused at a point before the retina, is known as myopia or short-sightedness. Do we understand this? Now, the second diagram shows us how are we going to correct it. Now, they are converging at a point before the retina. We want them to go to a point farther backwards so that they get focused at the retina itself. If we use a converging lens here, it will try to focus it more before, but we want it to go behind that point, and therefore instead of a converging lens we use a diverging lens, which is a concave lens, so that the rays should get focused farther rather than nearer. Do we understand this? This is how we can correct myopia or short-sightedness. Myopia or short-sightedness, rays are getting focused at a point before retina. In order to correct this vision, we'll have to use a concave lens, a diverging lens, so that rays gets focused at your retina. I'm going to give you a minute to draw this diagram, both of these diagrams. Defect is myopia, and how do you correct it? I'll give you a minute, and then I will give you some statements which are obviously there in your sheet as well, and we will discuss them. A minute to draw these two diagrams. I hope you understand this. Then these are the points that you should remember about near-sightedness or short-sightedness. Distinct objects are not clearly visible. Remember this. Distinct objects are not clearly visible. Don't get confused that near-sightedness means I can see nearby objects and I cannot see distant objects. It is opposite actually. In near-sightedness or short-sightedness, I also get confused. I have got a small brain which cannot remember things. Near-sightedness or short-sightedness means distant objects are not visible, but nearby objects are clearly visible. That is the first thing. It's ulta. In near-sightedness, distant objects are not visible. Do we understand this? Don't get confused. I get confused. I thought that I had myopia, but now I've understood that I don't have myopia. I probably had the other thing. Distant objects are not clearly visible. Nearby objects are clearly visible. To remove this defect, we need a diverging lens, which is a concave lens. We have seen that in the diagram, also noted down in the form of a statement. Concave lens. That's it. You don't have to write the entire statement. I think you are now wise enough that you will just write the important point, concave lens, and that you will remember this. Now, this is the diagram that you must also see. This is your eye. This is definitely not my eye, because I can see distant object clearly. Light is coming from a far point. Oh, sorry. A light is coming from this object. Now, there is a concept known as this far point, and please remember this concept. What is this far point? Remember, in myopia, I am not able to see distant object clearly, but up till some distance I would be able to see distant object. Do we understand this? I might not be able to see what is like 20 meters away, but I might be able to see what is like 5 meters away from me. Do we get this? It's not like, I don't see anything distance. I can see everything, but up till a particular distance, that particular distance up till which I can see things clearly, even though I have short-sightedness, is known as the far point. If I can see up till 5 meters clearly, I can see. I don't have short-sightedness. If I can see without specs, I can see up till 5 meters, but beyond 5 meters, I cannot see anything. That 5 meters becomes my far point. Do we understand this? Okay. So, if the far point is given to you, it is given to you. If the far point is not given to you, then you will assume that the far point is at infinity. If the reference of the object is not given, which object you can see, which object you cannot see, then you can take it as infinity. And using this formula of lens, we can find the power of the lens. Power of the lens is 1 by focal length in meter, or 100 by focal length in centimeter. From here, you will get, depending on what focal length of the lens you use. Since you are using a concave lens, the focal length would be negative, and therefore the power of the lens that you will use will be negative. Are you getting my point? How do I get the power of the lens in case of short-sightedness? 1 by V minus 1 by U is 1 by F. This is my lens formula. V will be the distance of the far point. Are you getting me? V will be the distance of far point. U will be the distance of the object which you see or don't see. If you know the value of V and U, you can find out the focal length of the lens, and hence you can find the power of the lens. If far point is not given, the far point would be given, sorry, if the distance of the object is not given, we will always assume it to be infinity. Do we understand this? A simple question will come. All these terms would be used there, far point. Then you will have to use your brains to understand what is to be done. I'll give you a minute to note this thing down. Remember, if U is not given, if the distance of the object is not given, reference of the object is not given, you will always take it as infinity. I'll give you a minute to note everything down. I'll be back after a minute. What I am going to do now is to give you a chance to become an, what do you call, ophthalmologist? Ophthalmologist, right? Doctors or who are specialized in vision. I'm going to give you a patient. And here is the description of the patient, and I want you to correct his vision. A person. And I hope that you are able to help him. A person who cannot see clearly an object kept at a distance of 100 centimeter. Find the nature and the power of the lens to be used for seeing clearly the object at infinity. So you have got a patient. 100 centimeter is the farthest he can see. Well, he is there at your mercy. Can you help them out? Help him out in getting the right lens, suggesting a right lens for him, and you will have a minute to show your expertise. If you can show your expertise in a minute, well, you will not get anything, probably, because he is not going to pay you any fee for this. This is free advice. This is a free, what do you call, shivir that you are organizing for patients who are suffering with myopia. Can you help him out? I am giving you a minute to do this. Well, it is quite simple how we are supposed to do this. This person surely has near-sightedness or myopia. He can see only objects till 100 centimeter. And I have to make him see object till infinity. So that is how I will correct his short-sightedness. So the reference object is kept at infinity. It might have been given that the object it has 200 centimeters. We will also discuss that case because even that case can come. Right now, the case is that you have to correct his vision for infinity so that he can see an object which is placed at infinity. Do we get this? Yes or no? To do this, what do? I put the value of U as minus infinity. The value of V is minus 100. It's given to you. I put it in the formula 1 by V minus 1 by U. So my 1 by U becomes 0. My V becomes equal to F. And it becomes equal to minus 100 centimeter. Therefore, I need to use a concave lens. Do we understand this? Power is 1 by F. So I do 1 by F. This F is in centimeter, so it will be 100 by F, or 100 centimeter becomes 1 meter. So 1 divided by 1 with a minus sign. Minus 1 diopters is the lens ka power which I need to use in this case. Do we understand this? So that is how you can correct the vision of this gentleman who want to see an object which is very, very far away. Now, if I change the question, and I'll give you one more chance, Kajal, to solve it for me. Instead of him seeing an object at infinity, if I make it as 200 centimeters, can Kajal and everyone else now correct his vision? This person does not want to see a very far object. He only intends to see an object which is like 200 centimeters away from him. He can only see up to 100 centimeters. So even if he can see 200 centimeters, it's 2 times of his vision. Can you now correct his vision and suggest him which lens he should use so that he can see an object at 200 centimeters? Can you do that for me? For him, for humanity, for everyone in the society? Can you do it? Yes or no? I'm looking for your response. Can you do it? Okay. So I'll give you a minute again to do your calculations and tell me what lens should he use. And 1 minute is good enough because I know since I am teaching you, you are going to be the best doctors ever produced on this planet. 1 minute is what you got. 1 minute is what you got to realize, utilize. I'll be back. So now comes my job to do it. 200 centimeters is where he got to see. So this minus 200 becomes your U. Yes or no? Do we understand this? Your V is already minus 100. Do we understand this? I just put it in the formula. 1 by V minus 1 by U is 1 by F. Instead of putting it as 1 by F, I simply put the power P. Why I should find F and then find 1 by F and then find the power? Let us put 1 by V minus 1 by U as P. Do we get this? Yes or no? So it simply becomes minus 1 by 100 minus of minus 1 by 200 is equal to the power P. Remember, I should not use, I have done a mistake here. I should not use what? I should not use 100 centimeters because then the power is 100 by P. So instead of using it as 100, what will I do? I will use it as 1. Are you getting my point? Yes or no? So it will be minus 1 by 1, minus 1 by 2. Do we understand this? Because I want the power in diopters. Do we understand this? So what I have done is instead of taking it in centimeters, I have taken it as minus 2 meters. And instead of taking this as minus 100 centimeters, I have taken it as minus 1 meter. Do we understand this? Can I have some raised hands? So comes your answer. Can I have the answer now? What is the power of the lens that he needs? It will be coming as minus 0.5 diopters. Do we see this? The power is not going, power is going to come as 0.5 diopters. Here the power was 1 diopter, and that is what I wanted to make you understand. 1 minus 1 diopter or 1 diopter is a very huge power. Someone of you is also wearing lenses here. I can see that. Beta, what your name? Oh, can't speak, so you can't tell me your name. Minus 1 is a very big power because I wanted to see things very far off. But then if I just reduce the power, I will not be able to see things farther off. I would be able to see things 2 times of what I deserve. That means power tells us how weak is your eye and how much external help do you need to restore your eye to the proper vision. And that is the reason I gave you this question, minus 1 diopter to minus 0.5 diopters. Obviously, with minus 0.5 diopters, this person would not be able to see more than 200 centimeters. But I think that is good enough. Are you getting my point? The concept of power in diopter and what does a big diopter mean and what does a small diopter mean. Minus 2 diopter is concave lens, plus 2 diopter is convex lens. That doesn't mean that minus 2 is less than plus 2. Here minus and plus only tells us which type of lens we are using. It's the numerical value that you must think about. Normally the power, if I remember correctly, somewhere around 0.15, 0.25 and something of that nature. It is never so high. It's so high that means your eye has gone completely. And I've also observed that with proper use of lenses, your eyesight may improve as well. Well, I will leave that for discussion at a later date. Right now, we must now concentrate on the next defect, which I think I have. So whatever problems we are going to do on this part will be based on me, that I am the patient and you are the doctors here. Let's see if you can help me out. So this is definitely my problem right now. And here comes my problem: long-sightedness or hypermetropia. I'm always hyper. Whatever I do is always hyper, whether it's teaching or doing anything else. I'm always in a hyper excited state. So that's why, my problem is also hypermetropia. Now, what happens in hypermetropia, which is probably what's happening with me? Case number one, the rays that are coming from nearby objects, they are not getting focused at my retina. They are getting focused behind my retina, and therefore I cannot read nearby objects. I have to get them to a distance far away. Then only I can read them properly. That is my problem. Yes, that is definitely my problem. When the object is too close to me, I just can't read it. How do I correct it? Things are getting focused behind my retina. So I need a converging lens to correct my vision. So that much I know, that I need a converging lens to correct my vision. My far vision is good. My near vision is wrong. That means I cannot see nearby objects clearly, but I can definitely see what is happening in the distant world. As far as the horizon goes, I can see what is happening. Nearby things I cannot see clearly. That is why I can see you guys, because you are far off and I can see what is happening there. I have got long-sightedness, far-sightedness, or hypermetropia. Number one is the defective eye, which is my eye right now. Number two will be the corrected eye, which you are going to correct it for me. You'll get 1 minute to draw these two diagrams. And remember, a convex or a converging lens is required to correct this defect of mine. And I'll give you a minute to draw these two diagrams. Well, then that takes us to what are the things that you should remember about hypermetropia or long-sightedness. If you remember one, you remember myopia, you just do the reverse of that and you will get hypermetropia. That means I cannot see nearby objects clearly, but far objects are very clear. The image of the object is behind the retina. In first case, it was before retina, now it is behind. To remove this lens, ulta, convex lens. There we had far point, here we had near point, the minimum distance to which I can see the object clearly. This is the near point. Getting my point? Near point, far point, getting my point? The image of the object is formed at the near point. If the reference is not given, it is to be taken as 25 centimeters. Remember, in myopia, if the reference was not given, it is taken as infinity. Do we understand this? Yes or no? No or yes? Again, the same formula, 1 by v minus 1 by u is 1 by f. 1 by v is distance of near point, it will be negative. 1 by u is distance of object. What object I want to see? Normally it is 25 centimeter, is equal to 1 by f, which is p. Power will be coming as positive. Distance of near point will be negative. Distance of object will be negative, but the power will be coming as positive. Are we there together on this? So you will have 2 minutes, 3 minutes to note these things down. And then we'll come back with a question, and the patient here is me. And if you don't correct me, I would be very angry. I hope you can correct my vision. I'll come up with a question when I come up next. I will be back. Now this I will be back dialogue is a very famous dialogue. Have you seen this movie Terminator? Arnold Schwarzenegger. This was a movie when I was probably younger than you guys, maybe around 10, 12, 15 years old. Terminator, Arnold Schwarzenegger. And he says, I will be back. And he keeps on coming back, keeps on coming back. So I'll be back after a minute to terminate this problem with your help. Terminator. Here comes a question, and the patient is definitely me. A far-sighted person, Aastik Udenia, has a near point of 60 centimeters. I think that is good enough. I can read at 60 centimeters probably. What power lens should I be using so that I can read a book at 25 centimeters? This is what I want to read. I can't read it. Patient is me, so be careful. If you give me galat power, I will be very angry. Give me the correct power lens and I would be grateful that I have taught you something in this class. One more chance to redeem yourself. Let's see who all can redeem themselves. I'll give you a minute to give me the power. So how I got to do this is pretty damn simple. No complications here. I have to see an object at 25. So my U becomes minus 25. Yes or no? V is minus 60. My near point is minus 60. My U is minus 25. If you want to use it in centimeters, you will get the focal length in centimeters. Do we understand this? If I use everything in centimeters, I will get the focal length in centimeters, and the focal length in centimeters by putting in the formula 1 by V minus 1 by U. The focal length in centimeters will become 300 by 7, or in meters it will become 3 by 7 meters. Do we understand this? If I do the reverse of this, I will get the power. So power will be 7 by 3 diopters, a very high power of plus 2.33. Now I am getting a bit nervous. I would be using a very high power if I have this condition. Do we get this? Yes or no? No or yes? Pooja, Kajal doesn't seem so confident. What's the problem, beta? We don't understand this. Yes or no? Okay. Then I'll give you a minute just to note this down, and then we'll move on to more typical case, which is definitely not mine. That I can't see far object, I can't see near object, and what I can see. That's a question. That thing is coming up. I will be back. Then comes the case where I can't see far objects, I can see near objects, which is the case with my mom, I guess. She uses a bifocal lens. One is for treating her myopia, and the other one is for treating her hypermetropia. That condition is known as presbyopia. She has presbyopia. I just came to know now. In this case, as you can see on your screen, both near and far objects are not clearly visible. To remove this defect, two separate spectacles, one for myopia and the other one for hypermetropia, used. Bifocal lenses are used. You must have seen bifocal lenses. Now, there are different types of bifocal lenses that I have come across. I don't have expertise in that, but in one, you will have two separate lenses and you will see a definite line between the two lenses. Those are cheap to manufacture. The other one is on a combination lens where you don't see that line, and those are quite expensive to manufacture. The major cost of the spectacle is the lens. If the lens is bifocal, well, it will cost you more. In my case, probably I only have one defect, hypermetropia. Probably my lens would be cheaper, and probably I would get a better frame for a better price. My ma's case is different. She has a bifocal and she does not use that line wala lens. She uses a combination lens. That is the next defect. You must know all these defects. The last one is astigmatism. What do you mean by astigmatism? It is the imperfection of the complete spherical shape of the eye lens. In this defect, eye does not see object in two orthogonal directions clearly. Perpendicular directions, you are not able to see things clearly. It is removed by using cylindrical lenses. So you must remember where cylindrical lenses are used, where bifocal lenses are used, where simple concave lens is used, where simple convex lens is used, because this is a part of your learning and you must remember this. I'll give you a minute to note down all these points of presbyopia and astigmatism, and I'll be back after 2 minutes. Note it down. Well, I think you have gone through this. So, as a matter of fact, we are done with your topic on ray optics. I'll just give you a quick preview of what we have done till now. We started with plane mirrors. A plane mirror always produces a virtual image of the same size at the same distance as the object itself. Then we went on to spherical mirror, curved mirrors, concave mirror, which is a converging mirror, convex mirror, which is a diverging mirror. We saw their mirror formula. 1 by V plus 1 by U is equal to 1 by F. Do we remember this? We saw the magnification formula for mirrors minus V by U. For a real image, it is negative. For a virtual image, it is positive. HI by HO. We saw the sign convention. We solved some problems over there. Then we moved on to refraction, laws of refraction. We saw Snell's law. We saw what is refractive index. We saw what is absolute refractive index. Refractive index of vacuum or air is taken as 1. Everything else, the refractive index is more because the speed of light is less. Sin I by sin R is mu. We have also seen Snell's law. Then we saw refraction by a thin slab. We saw refraction by a prism. We saw dispersion. We saw deviation. We saw combination of prism, dispersion without deviation, deviation without dispersion. We saw lenses. We saw refraction by spherical surfaces. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Do we remember this? Can I have some raised hand that we remember this? We saw the lens maker's formula. 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2, where mu is the refractive index of the lens with respect to the medium surrounding it. In the last, we saw optical instruments, microscopes and telescopes, simple microscope, compound microscope, astronomical telescope. We saw their differences. And in the last, we came to my problem, hypermetropia, hypermetropia and myopia, and we saw how they are corrected. You are done with your ray optics. I have covered almost everything that can ever come in your examination hall. I'll give you 5 to 10 minutes to go through each and everything that I have done in ray optics. If you have any problem, you tell me, because now we'll begin the next lecture, and that will be on wave optics. So in the next class, in the next lecture, we will be dealing with wave optics. I'll give you time to go through what we have done in ray optics. Take your time. If you have any problems, let me know. I am here. Unless you say that, sir, we are done with ray optics, we have no issues with ray optics, I will be clearing the doubts, and then we will be moving on to wave optics. So you have time, go through it, and I'll see you in the next lecture.